let ABC be a triangle with circumcenter O. So let's draw the circumcircle. I don't think I've drawn a circumcenter this whole session. That's crazy, isn't it? How could I not have drawn a circumcenter the whole session? Let the tangents, okay, so we have like a symmedian type of configuration. The tangents meet at point D. I'm probably going to need to shrink this a little bit. There we go. AO intersects BC at E. M is the midpoint of BC. So obviously OM and D are collinear. AM meets the circle again at N. So basically CAN is BAB because of Submedian Theorem. I don't know if Submedians will trivialize this, but we'll see in just a second. Let F be the point so that AMEF is cyclic. I can do that. Prove that Fn bisects MB. All right, so that's interesting. We have like a bisector of MB. I could let it meet at a
parallel.
What?
They look like parallel.
They look parallel. FG and CD basically look parallel. Oh, but they're not necessarily. That just looked like it. So yeah, let me change it a little bit there. Now they don't look as parallel. So looks like projective geometry, right? Just maybe project through N because A, B, and C is harmonic, right? So if we project through point N, if we take MGD infinity, M goes to A, G goes to F. So M, G, D, I think maybe N, D, and E are, no, N, D, and E aren't collinear. But basically angle BNA is CNH. So AH is parallel to BC. And so, what do we have? AHF, and then we just draw the perpendicular. Let's see what that does. So AIHF, we want to show that cross ratio is 1. Is it an isosceles trapezoid? Not. Let's see. AIHF. How is F defined? So AMEF is cyclic. Okay, so we want to show AIHF is harmonic. What if we project Maybe there's another way to use projective geometry here. I thought projecting through n is like the most natural way to do it. Sure seems like it. Okay, so AIHF. Maybe it's worth drawing AD. But I kind of use the, I mean, I've used the fact, like, I know AH is parallel to BC, so I think maybe that should be good enough. So I think, so I is the antipode of, so IO and J are collinear. I don't know. Maybe I project through J. So, and J, M, and H are collinear too. Are J, E, and F collinear? Looks like it. Is that obvious? So that would probably make it easy then. Why are J, E, and F collinear? Is that an angle chase? Because if we knew J, I, H, and F, if we knew J, E, and F were collinear, then we could project A, I, H, and F onto BC, and then that would solve the problem. I think it would. Actually, where would I go to? So let me start from the beginning. So I want to show G is the midpoint of MD. I project through N, so I get A, F, I, H, and then I project through J onto BC, so I get K, this point, M, and E. But K, Can
you hide other things?
what should I hide? I feel like I'm using.
After proving J, E, F are collinear, we can make it appear.
So once J, E, and F are collinear, once we show that, we can solve the problem.
It's true that, but can you hide other unnecessary things? There are so many lines.
Yeah.
If we think we need that, we can draw.
Okay. So should I hide point I? I kind of feel like that point I could have helped with the projective proof. That's the thing. So FEC is equal to angle FAN. Which is FJN. So yeah, I think so. EC is parallel to JN, of course. So We know angle FEC is FJN. Is that enough to show? We want to show FE and J are collinear. Yeah, if FEC is FJN, that proves that FE and J are collinear because we know JN is parallel to BC. Okay. So yeah, I've proven that FE and J are collinear.
Now we can draw the other lines.
Okay.
As a good approach.
Sounds good. Is there another line too? No. No, that was it. Okay. All right. F. Oh, I think this line, yeah, accidentally hid this one. So AH at IF. I want to show that's harmonic. But let's just check that that's actually true just for fun. Okay, so is it harmonic? Yes, it's harmonic. Okay. So that's the same as Km, this point, and E are harmonic. KME, yeah, what is this point right here? Is that like the foot of the angle bisector? That would be interesting. No. So maybe we could project onto AOE. So I would go to O, F would go to E. What would H go to? Would go to this point. HJ intersect AO. I can label that point. So we want to show A, O, L, and E are in harmonic conjugation. ALH is similar to LME. And we might be able to use that to show they're in harmonic conjugation. Let's see. So I wonder if it's just, so showing A, O, L, and E are in harmonic conjugation, it's the same as showing that I think it's the same as showing KL. I wonder if KL is concurrent. I think it is, yeah. It's the same as showing that KL, AM, and OJ are concurrent. So yeah, there's just so many different ways of seeing this. But yeah, let me see. So yeah, maybe we could show it using, like Akan mentioned, the ratios. So we know AL over LE is LM over LH. Yeah, what would AO over OE be? AO over OE. So triangle JIN is a right triangle, right? And O is the midpoint of the hypotenuse. So maybe that helps a little bit. So yeah, what is AO over OE? I wonder if HO and K shouldn't be collinear. Yeah. So we could try projecting through point M, right? So we have AOLE. We could project through M. Oh, it's trivial because AML is an angle by MO bisects angle AML, so that's harmonic. So yeah, that solves the problem. All right, so I'm going to write it up. Yeah. All right, so first we wanted to show, so yeah, I added a lot of stuff to the figure, obviously. Let me see what I actually needed. So I think I needed it all. So what did I do? I first want to show AIHC is cyclic. I projected through point J. So yeah, let me first hide a bunch of stuff. So it's hard to even know where I began here, right? This was part of the problem. Hide this for now. Hide I. Hide L. Projecting through H also solves it. Interesting. All right, so let AD meet the circle at J. And let FN meet MD at G. And then we can project. Okay, so we're going to want to use the Submedian Theorem. So first of all, how was point N defined? Wait. AM. Okay, I should draw the line through AM and N. So by the Submedian Theorem, angle CAN is equal to angle BAJ. And so that means that JN is parallel to BC. So let DN meet ABC at H. So by symmetry, so AM and N are collinear means that JM and H are collinear. Oops. I'll just say by symmetry, J, M, and H are collinear. Or I'll say this: AH is parallel to BC, and J, M, K, or J, M, and H are collinear. Now I wanted to show J, E, and F were collinear, so I'm going to try to do that now. So I could show angle FEC is FJN, so that's a strategy. So we have angle FEC equals angle FAE. Is that right? Now FEC is FAM, which is angle FAN, which is angle FJN. And that means that FE and J are collinear. See how this comes out in the LaTeX. And, ooh, that was weird. Let me get rid of this. Just try this. See how it comes out. It's a little better. So FE and J are collinear. And once we know that, so obviously D, M, G, and O are collinear. I'm not even going to write that, but now we can do all our projections. So projecting through N onto the circle ABC, we have DMG infinity. Oops. DMG, and I'll say DM infinity. That's equal to H, A, G goes to F. Oh, now here's where I need to create point I. HAFI. And then projecting through J onto AE. We have HAFI is equal to okay, let me unhide that point L. So HAFI is equal to L A EO. And then and that's equal to -1 since MO bisects angle AML and angle OME is 90. And then once we know that, that means that this cross ratio was equal to -1, which means that Fn bisect some D. All right. That was a fun one. So yeah, I kind of just defined, I didn't write the definition of I and J, or I wrote the definition of J, but not of I and L, but I'll just assume whoever reads this can figure it out. Let me make some more room here. And then I will, yeah, this is just for people viewing it on YouTube so that they can see the last line. All right. So here's the last problem. We can go back to that earlier problem too. This one looks hard though. I tried this one before and I couldn't figure it out. So if we can do it, I think that would be really cool. All right, so we have a triangle ABC. K, L, and M are the midpoints of each of the sides. We went through these fast. Wow. But this one, I'm sure will be pretty tricky. The incircle, I never drew an incircle either. This is amazing. I don't think I drew an incircle at least. It touches side BC at point D. So the line, yeah, so we have a line, this is really interesting. It passes through the midpoint of ID. Whoops. So there's not many problems like this that involve the midpoint of ID, but it passes through it and it's perpendicular to IK. It intersects LM, which is the kind of the midline at point P, and we want to show angle PIA is 90 degrees. How did you learn losing the algebra section? So yeah, the algebra, you could just click the calculator right here. I kind of just played around with it. So it's if you go on the internet, like it's just like so the notation for incircle is just incircle ABC. The notation for the center of a circle is just center of that circle. Yeah. So yeah, it's pretty nice. But yeah, I probably should have used it actually a little bit earlier, but I3435 convinced me to start using it more. So, and yeah, Evan Chen uses it a lot on his channel, for those of you that watch his channel. Okay, so, whoops. So we want to show, okay, so EP is perpendicular to IK. And we want to show angle PIA is 90 degrees. Let's just check that. It's an interesting problem. Let me draw PI and IA. So yeah, we want to show that PI is perpendicular to the angle bisector from A. Actually, I'm not sure if this was the problem I saw before. I think it is. So yeah, it's really random. How would we show that?
I think we can drop the altitude from A to BC.
From A to BC. All
And
right.
extend Ki.
Extend Ki. All right.
Dropping the altitude gives 2 cyclic parts.
Okay. Gives 2 cyclic quads. So MFKL is cyclic, right? That's a 9-point circle.
And the point where altitude cuts ML is cyclic with the point where IK cuts PE. If we assume that to be F or something
Okay.
else.
I like it. All right. So let me. Okay. So this is cyclic. Again, so those are cyclic kind of. That's what you're saying?
And we want to show that PIGA is cyclic.
Ah, we want to show that PIGA is cyclic. Okay. So
We already know the angle IAF. We can try finding the angle IPM.
IBM. So we know IAF. We could try finding IPM. Yeah. Okay. So IPM. Maybe we could let PI cut BC at a point. Not sure. So we want to use that E as the midpoint here. Maybe we could use project. What if we project through point H? Just trying out stuff. So yeah, these circles are actually tangent. It probably is completely irrelevant to the problem, but by Feuerbach's theorem, I've never done Feuerbach's theorem, but they're tangent. So if E is the midpoint, then basically, if we draw this and we let it intersect BC at a point, then K N D. So let me drop the altitude from H. How did we get point H? Oh, we just defined it ourselves. So those points are in harmonic conjugation. I'm not sure if this will help or not, but yeah, I'm just trying it for a second. All right. So N, O, K, and D are in harmonic conjugation. And so that means maybe it's worth, I don't know if I'm just drawing too much. Wait, are these collinear with the Feuerbach point? Oh, I was going to say, that would be really weird. Is MN perpendicular to BC? No. Can you extend PI to BC? Yes. Oops. Yeah, I know it's getting kind of messy, so I might start erasing some stuff soon. This thing covers it up. I don't know how to get rid of it. Go away. There we go. PIA. Let's see. So yeah, we want to show PIGA is cyclic. We know angle GAI, like Anmol said. We want to find angle GPI. Obviously, that's the same as angle PQC, or IQC if you want. So another, we could also show that AI, well, we know AIFQ is cyclic. Does that just, oh, but we don't know that yet. We want to, yeah, we could try to show AIFQ is cyclic. It might be just as hard, but can I also extend AI to BC? Yes. So yeah, I'm going to want to erase some stuff. I'll erase, what did I add? 0.0. This. We'll erase that for now. So AI meets BC at 0.0. Let me make this a little neater. Oh, I don't know if I need point N. Maybe it's useful. Whoops. Well, the Feuerbach point is getting close to the midpoint in this diagram. There we go. Wouldn't it be cool if the Feuerbach point was the key to the solution of this problem? All right, back to the real world. How do we calculate angle GPI for angle MPI? P. Let's see, MPI. P is the, I don't like how P is defined. I feel like, what if instead we, so you're drawing the perpendicular from E to IK. So yeah, maybe we could use the IM lemma somehow, but I don't, let's see. I feel like it's better to let P prime be the cyclic point, and then to show that EP is perpendicular to IK. That seems more intuitive to me. So I'm going to do that. I don't like that definition of P. Whoops. So define P like that, and or call it P prime, let's say, so we don't forget. And then we want to show EP prime is perpendicular to IK. I like that better. Although it doesn't mean the other way couldn't work. So IK bisects AD. There's a lot of properties of, so yeah, IK, it bisects AD. So it's a median of triangle AKD. Maybe we could use the Submedian theorem. Can you reflect D across K? Yes. I can do that. So that will meet the end circle at the topmost point. Maybe I should hide the 9-point circle. I'm not sure how useful the 9-point circle is. And even if it is, I'd probably just remember it. So yeah, so I, D, and P are collinear by HM theorem. We want to show AD prime and P prime E meet on the circle. Let me call this Q instead, just so we don't get confused. We want to show AD prime and P prime E meet on the circle. Interesting. Does AI cut the smaller circles in 2 halves? Yeah, because AI is an angle bisector, so it's. I guess the question is, does AI pass through the center of that circle? It might. Let's see. No. So it cuts this circle in half, but it doesn't cut this circle in half. All right. So I wonder if there's some kind of a homothety, because let's see, E is the midpoint of IB, and Q is the midpoint of, and I is the midpoint of QD. So yeah, we have a bunch of similar stuff here, for lack of a better word. So yeah, IO is an angle bisector of DIK. So yeah, is IO, yes, IO is the bisector of DIK. So then Q1, ODK are in harmonic conjugation. I like it. And we can project through I onto the circle. So A, P prime, yeah, but we don't know where D and K go. Maybe it's still worth doing it. So yeah, we know those are in harmonic conjugation. It seems like I is the best thing to project through, right? So maybe we could project through I onto AD prime. I think that might be the best, AD prime. So what would K go to? Oh, those are parallel, that's right. So wait, what if we project those 4 points through I onto AD prime? So K goes to the point at infinity, O goes to A, D goes to Q. Basically, if we draw this point, we want to show that Q is the midpoint of AP, I think. No. Hold on a sec, Hakan. Let me just think this through and then I'll read what you put. So P, A, Q, this is weird. I thought it would mean that Q is the midpoint of AP, because This. Oh no, IO is not an angle bisector BIK. I was wrong about that. So yeah, that is my bad. Maybe letting AD, yeah, it's. Or at least I don't think. Let me just do a quick check, but I think it's very unlikely. I think I made a mistake. That's, oops. Yeah, no, it's not an angle bisector. So yeah, IO is not the bisector BIK. That was my mistake there. Maybe let AD prime cut the circle at R. Let me try that. So if I let AD prime cut the circle at R, and I let P prime R meet ID at E prime. Oh, but that was assuming harmonic stuff. Okay. So yeah, we want to show AD prime and P prime N meet on the circle. So hold on a sec. So EI is equal to ED, and we want to show that EP prime is perpendicular to AD prime. If H is the orthocenter of BIC, then H is the pole of ML. Interesting. That sounds kind of like that's probably like a well-known fact, right? Or it seems like it might be, but I never heard it before. So maybe that could help. Yeah. All right. Okay, so yeah, IK is parallel. Yeah, we want to show EP prime and AD prime meet on the circle. We can try proving that the polar of P is perpendicular to RQ. What is R? Touch points of incircle with other two sides. Okay, so let me draw the polar. There's actually a polar tool in GeoGebra. Where's the polar? Sorry, just give me a second. Polar here. We could show that that's perpendicular. So basically you're saying I draw a line between this and the tangency point, it would be perpendicular. Basically, you're kind of saying that that's parallel to AI, right? Let's check it out. So, looks true. Yeah, okay. So I kind of see what you're saying. So that makes sense. I'll call that P. Oops, sorry. I like the strategy of showing that P prime E and AB prime intersect on the circle. So P prime E is a median of this triangle. So we have like, I wonder if like we could have corresponding figures somehow. So PE is a median in PID, and maybe we could get another median, and we could show so yeah, I kind of want either AD prime or IK. So IK is a median in IDD prime, but it's not the median I want. Yeah, what's a point? What if I draw this point? Kind of making a few guesses here. We want to show IK is perpendicular to P prime E. Can we make IK, I mean, IK could be a median, right? Like, I wonder if we let IK meet the circle at a point, keep showing P, I hate this. So let's see, if we call this, I don't know, X. Is X D prime similar to PID? I want to make a point. XDD prime 107.7. PID 105.8. Let me try this instead. So let me try this. Then XD prime. Oh, hold on a sec. So this is 107, and PID is 105.8. So it doesn't work. I could try one more. I could try this point. Just check. Oh, wait a sec. I think that might be our magic point, 105.8. Yes. Okay. So I think that's a good strategy. So I'm going to call this point X. So where I, K meets the altitude. And I'm going to show, I wanted to call it X, not K. So call it X. And then we want to show X P B prime is similar to P prime I D. That would solve it. So how do we show that? XDD prime we want to show is similar to PID. And then since we have two medians, they would both be perpendicular. This is, whoops, what is going on here? I wanted to hide, not delete. All right, so, I mean, a spiral similarity would take one to the other. What's the center of that spiral similarity? Can you reflect D over P prime? Yes. Are you guys okay if I delete point Q1 for, or what? Okay, so it's all the way up to there. Okay. Sure, there's a solution that uses that point, but it's probably not going to be the one we come up with. Okay, so call this Y. So is AY parallel to BC? Yes, basically. Yeah, you beat me to it. AY is parallel to BC. So, but I like this point X here because it means we want to show XDD prime is similar to PID. EP prime is parallel to IY. That's interesting. EP prime. Well, how could that be? EP prime and Y are collinear. So, EP prime is the midline in triangle DIY. Oh yeah, that's true. So what? Yeah, I guess I must have just got confused. Yeah, no, they're parallel. Is GD parallel to AI? I don't think so. It looks like, yeah, I think these are concurrent here. Right? I think that's like a property. Maybe it's a coincidence, but I don't think it is. Yeah, no, those are collinear. Okay, so maybe we could do an angle chase. So first of all, we want to show the pointy angles are equal. So we want to show P d prime d is P prime di. Okay, so I can show it's driving me crazy how this keeps saying point P, which I don't want it to say. It is sufficient to show that yi is perpendicular to ik. Yes. One sec, guys. I'll be right back. All right, thanks for waiting. Oh, so we're done. Okay. So EH is perpendicular to IK. No, we're trying to prove that, right? That EH is perpendicular to, well, I guess it depends how we define things, right? I guess, okay, so if you're defining H to be, can I define P as in the problem? Yeah, I can do that. Okay, so then you think that solves it. Let me just read through what you did for a second. So AD prime is parallel to IK, and EH is parallel to IY. EH okay, so that would prove that angle XIY is 90. I think okay, so YI is perpendicular to IK, and then was it like just a spiral similarity kind of thing from there? So once we know YI is perpendicular to IK, I guess once we know YI is perpendicular to IK, how do we do it from there? That's kind of what I'm wondering. Oh, so once we've shown that YI is perpendicular to IK, how do we finish the problem from there? Oh, because YI, I think actually, I'm not sure. All right, I think, because I think you're trying to show that xdd prime is similar to PID, right? So you showed, okay, so the medians are perpendicular. That's given in the problem. Two of the sides are perpendicular. And the other side, okay, I think I have an idea here. So I'm going to start writing it out. So I'm going to define P as in the original problem. So I'm going to delete this circle. Let me delete point N. I don't think I need this either. Whoops, what happened there? Oh, I want point X. Okay. Okay, what is O? O is just where AI. I don't even think I need. Do I even need point O? Maybe not. So yeah, I'm going to show that xdd prime is similar to PID. So hold on just a second. Let me see what I need and what I don't need. I don't think I need this. Don't need that. I don't even know if I need this. Okay. So let's make some room here. So let D prime be the reflection of D over K. Let AD prime meet the in circle omega at Q. By the video on the IM lemma, A, Q, and D prime are collinear. Or I should say D, I, and Q are collinear. So D, I, and Q are collinear, and also IK is perpendicular to AD. All right. Or parallel. And then we're saying let Y be the reflection of D across P. Actually, you know what? I don't even know if we need point Y. Well, hold on just a sec. So I might not end up using point Y, but So I'll say let IK meet AF at X. Then XK and PE are the medians in triangles. XK is perpendicular to PE. So we have two perpendicular medians in those two triangles. And the two of the sides are perpendicular also. So ID is perpendicular to so yeah, we have, let's see, we have ED is perpendicular to KD prime. We have EP is perpendicular to IK. And then last we have, so yeah, if all three sides of two triangles are mutually perpendicular, does that mean the triangles are similar? I think it does. Yeah, it should. So, so I want to show XD prime is perpendicular, either XD prime is perpendicular to PD, or XD is perpendicular to PI. So is XD parallel to AI? I think it might be. Yeah, I think XD is parallel to AI. Let's see if that's obvious. So so first of all, AXIQ is a parallelogram. So that means since ID is equal to IQ, okay, so yeah. So first of all, AXID is a parallelogram. And so whoops, I'll say AXIQ is a parallelogram, so that's obvious. And then IQ is equal to ID, means that AXDI is a parallelogram. So YI is perpendicular to AD prime. So I actually think I have a solution that doesn't use point Y. First, let me write up my solution, and then I will add your solution. So AXDI is a parallelogram. So basically, we want to show PI is perpendicular to XD. Yes, so what was I doing? I was showing that XDK is similar to PIE. So or I could show XKD prime. I feel like I'm close here. So AXIQ is a parallelogram. Okay, so I'll just draw the solution using point Y. So YI is perpendicular to AD prime. Y, I'm just trying to remember, why was that? So, oh, because YI, so IK is parallel to AB prime, which means that YQ is parallel to IP. Oh, okay, yeah, so, okay, so we have, so I'm going to delete some extras. So DI is IQ and DP is PY. That means that YQ is parallel to IP. And then, and then you showed that YQ is perpendicular to AI. So we have YI is perpendicular to AD prime. Why was that? Let's see. Why is YI perpendicular to AD prime? Oh, because YI is parallel to EP. So yeah. So okay. So we also have YI is parallel to EP. And that means that YI is perpendicular to AD prime. Okay. So Q is the orthocenter of triangle AIY. All right. So yeah. So YQ is perpendicular to AI, and so IP is perpendicular to AI. All right. So all right, this is a really nice solution. So I'm going to delete all the X stuff that I added. That's just junk. I think there is a solution using point X. But I will just do this one for now since we're out of time. So, all right. Let's just review it one more time and then I'll end the video. So, whoops. All right, so D prime is the reflection of D over K. So we have DI and Q are collinear. Let me shrink this a little bit for a sec. So DI and Q are collinear. IK is parallel to AB. And then Y is the reflection of D over P. Since DI is equal to IQ and DP is equal to PY, we have YQ is parallel to IP. We also have YI is parallel to EP for the same reason. So YI is perpendicular to AB prime. So yeah, so YI is perpendicular to AD prime. So Q is the orthocenter of AIY since IQ is perpendicular to AY. And AD prime, we said was perpendicular to YI. So did we even need that YQ is parallel to IP? I think we didn't need it because of this step right here. Yeah, so yeah, it's a lot of, yeah, reflecting stuff when there's an arbitrary midpoint. So yeah, very nice solution. So yeah, thanks for that, Hakan. All right, so we're out of time for today. So thanks everyone for participating. So if you like this, subscribe to my channel. So yeah, our sessions are on Sundays at 10 a.m. US Central Time. So feel free to join. Email me at mgreend801@gmail.com if you'd like to join. Thanks everyone.